We're talking about high altitude airspace here, above flight level 600 in the US. It's currently occupied mostly by military aircraft. In the past decade or so, new entrants like supersonics, hail fixed wing, and balloons that operate in different ways than what we've currently seen. It's not just your typical aircraft. And the fact that they're all going to be operating in the same airspace with each other, it proposes a super challenging and interesting problem that we can solve together. My name is Michelle Cady. I'm the ETM Program Manager for the engineering portion of the Class C Upper Airspace Operation Development. I work with Sherry Majaritz, who's developing the concept on this work. Our objective is concept development and engineering analysis to support future high-altitude operations. I wanted to be an engineer since I was little. I picked a track in aerospace engineering because it's clearly the coolest. But it's exciting, honestly. I'm getting to utilize those skills to work in a field and on programs like ETM that really interest me. My real interest is supersonics and high-speed aircraft, but all of these new entrants that are coming up are extremely interesting to me. The thought process behind creating these things, the new atmospheres that they can reach and abilities that they have is just very cool. Our main focus is trying to figure out how exactly that these different aircraft are going to interact. The disparate vehicle types mean that we have to take a different look at how they're going to interact with each other, especially since we're mixing unmanned vehicles with piloted vehicles and fast movers with slow movers. It's a whole different ballgame than what we've seen before. Given the predicted increase in commercial operations in high-altitude airspace, we need a management model that provides flexibility for these operations. We're going to be trying to do this with operator coordination from one level to another and leveraging principles of cooperative separation that we've learned through UTM efforts. And we're also going to take into account these unique characteristics of all the high-altitude vehicles and specific operational needs. There's minimal services provided in Upper Class E currently. There are operators that are flying today and they coordinate with ATC as appropriate, but those solutions aren't scalable for how many aircraft and the different types that we anticipate in the future. These vehicles provide communication infrastructure support, internet in areas that don't currently have it. They are able to move around the world and provide it to different locations. Another thing that these vehicles can provide is commercial transportation. That's the supersonics and potentially hypersonic aircraft transporting people at much quicker speeds. Environmental data collection is something else that is on the table. Sampling the atmosphere or scanning for forest fires are all applications that these vehicles are able to provide in this airspace. The current model that we're looking at is a cooperative approach for above flight level 600. Cooperative separation is a traffic management approach that relies on information sharing between the operators. This ultimately provides situational awareness to operators and VFR-like flexibility for high-altitude operations. The FAA's main goal, obviously since this is still our airspace in Upper Class E, is to maintain the safety and equitability between all of the operators. There are a multitude of new information sharing techniques that we are going to try and utilize. We are currently collaborating with NASA and industry to decide how operators can most effectively communicate and share this airspace with one another. In this specific project, there's real-world opportunities that these new entrants get to actualize, and it allows operators to decide how they want to interact with each other by agreeing on these community-based rules while we're developing the concept, as opposed to coming in later and just having to follow what's already been established. I want these operations to be realized because I want to be able to fly on a supersonic aircraft one day or get Wi-Fi from balloons in the middle of the ocean. All of these operators provide such unique capabilities. We want to be able to support these operations by promoting Class E airspace management effectively. There's a need for high altitude or stratospheric operations throughout the world. We're hoping that our ETM concept will eventually help to inform other countries' development of stratospheric and high altitude operations. If you want more information, you can go to our ETM website to get an overview of the project and see some current documentation that we have up there.
Good afternoon, ladies and gentlemen. I'm Marcello Mannino, responsible for operation marketing for ENAV, ENAV Group, and we are going to analyze and introduce you the future ATM challenges and how ENAV is going to approach and have a vision connected to the new traffic challenges. So, traffic management industry has several challenges to cope with in order to keep improving the service level and maintain the business sustainable. And this has been the effect connected not only to the market pressure generated by the COVID-19, the volatile levels of future demand, the travelers' demand, the cost efficiency connected with the pressure streamlined for aviation and structural changes, the environmental issue connected with emission, noise, and density of traffic. So the ATM response will be connected to scalable and flexible system, improving the network and the sector design, supporting the new airspace design concept for introduce new concepts such as cross-border operation, urban mobility, and UTM platform. The digital and the technology as well are connected to an automation process that rely on the data collected during these phases and produce a predictable environment connected both with ATM, CNS, and satellite technologies. Together with the market pressure, we have a main driver of strategic evolution indicated by ICAO Eurocontrol in a plan that lasts 2020-2035, in particular the European Capacity and Resiliency Challenges, the airspace structure studies, the decoupling of services and local infrastructure, the digital transformation, virtual center, the ICAO and ASBU that imply the adoption in operation of many of those specific things. The SWIM implementation is part of the ASBU implementation, a new business model connected to the ATM data distribution and data service provisioning, and last but not least, the artificial intelligence and the machine learning component associated with that. Therefore, the ATM industry is evolving towards optimized operation through advanced technology solutions that combine operational concept and technology solution, in particular with a focus for optimized airspace and advanced and technological automation. We will see this, as I mentioned before, for cross-border operation, not only for the European area, but also for the Pan American area, for the African area, and many other constrained areas such as the Asia Pacific. The transformation of the flow-centric operation to overcome the scalability limits of the sector is another factor that imply a better and efficient airspace structure. Virtualization of air traffic services, automation, reducing the cost of staff. The solution of flow-centric operation will also distribute the cost in order to cope with the dynamic airspace sectorization and configuration. A seamless data exchange as well as will support a much more operating and optimal concept of operation among the NSP stakeholder. Okay, so which are the enabler for this challenge? So the main ATM enabling technology, among the enabling technology that we have in the list for the industry, there are artificial intelligence, as I mentioned before, machine learning, data sharing, and remote and digital tower. These, in this picture provided by Eurocontrol SRJU, list a set of technology that I mentioned. So for the trajectory, remote tower system, AIE for ATM, so artificial intelligence, data sharing, data link, satellite technologies such as new micro satellite services provided right now by Aerion, infrastructure as a service to support and optimize an eco-sustainable ATM infrastructure. And on the right part, we see the impact that rely mostly on prediction, so an high efficiency and optimization of operation and optimization of the control activities. So it's a bunch of improving through application of those technology the ITM infrastructure. If we summarize what are the list of those technology enabler, we will see this scenario that is fundamental for the development of the automation among services in the ATM industry. If we go from the lower part, we will see advanced flight data processing system for the trajectory, remote tower operational concept, a SWIM architecture to distribute the data among different stakeholders such as military operation, surveillance data, meteorological services that are fundamental and critical for managing big area of airspace. The new advanced service for new user, I'm talking about UTM operation in BV loss, UAM or urban mobility, and last but not least, satellite technology, as I mentioned before, to support a much more efficient and tracking of operation for both aircraft and the new supersonic Class E airspace user that are connected with the adoption of new jet for travel. So just to recap, the final implication are a business model that evolved from asset-oriented to service-oriented for flexible system. We move from a national approach to the ATM management to a regional and global approach through digitalization and virtualization of technology. This service provisioning decoupled from a physical infrastructure and location, thus means interoperability among different stakeholders. Leverage automation with analytics to efficiently and safely handle the growing amount of data, thus means artificial intelligence, thus means introduction of automation, that means machine learning, and at the center also the satellite technology that will support a much more connected, interoperable world. In this approach, ENAV creates a combination of knowledge and proven operations that in practice and best practice. What does it mean? So we have the air traffic operation control competencies. We have an excellence in technical software development and research and development program to our main company groups, such as the ENAV and TechnoSky. This combined together create a very huge amount of power that is connected to a set of integrated COTS product solutions that are devoted both to the NSP with the flight to the UTM, to the airlines, to the airport, and in particular to the airport infrastructure. So we are proposing our bunch of competencies and knowledge with a cutting-edge of ATM solution proven in operation for an efficient and safe air traffic services. In this sense, what we have as a result is a set of common information management layer that support the AIM function, the design and CNS group, the ATFM and airspace management group, fed by different sources of data through a SWIM infrastructure. And we'll see on the left side the set of product, and on the right side the final package that comes as ATM data to a SWIM infrastructure to supporting different ATM stakeholders such as NSP, airlines, airport, flow management center, vehicles, and planes. So what else? ENAV, we would say, is the total partner to face the demanding challenge of the future eco-sustainable ATM, covering a bunch of area that goes from the aeronautical information services, the aeronautical information management, the traffic flow management, the UTM platform, the ATM platform, as well as with the latest co-flight cloud services, combining the ATM information, the ATM solution for a future interoperable total platform for ATM, together with a set of specialized services unique as an SP provider, because we are more than 1,700 people with ATSEP certification, providing engineering excellences and aeronautical excellences in terms of studies, procedure design, feasibility analysis, safety and security assessment services, aeronautical publication. So just to summarize our, let's say, competencies here in this final slide and a final thank you that I provide you guys, we would say that ENAV Group is a wealth experience, drive and understanding to help a customer achieving the strategic objective by providing wide range like standard services and product based on different area with a proven operational experience applied to the current requirement coming from the main recommendation of ICAO and from a main recommendation coming from the European Community. So you can see here all the area in detail that the ENAV Group can cope together with its company group that are TechnoSky, IDS-ENAV, D-Flight, and the participation in Aerion and SSP for the satellite competencies. So thank you very much, and I will be very glad for a future connection with you if you have any question about our solution and capabilities. Thank you.
Since 2014, Cesar Deployment Manager worked successfully on coordinating the modernization of European air traffic management involving all aviation stakeholders. With the EU's financial support and the cooperation of air traffic management institutions, the aviation industry has invested close to €3 billion in 343 modernization projects. Over 150 of these are already completed, digitalizing and decarbonizing the European airspace. Almost 100 civil and military airports, airlines and air navigation service providers in over 32 European countries are involved, along with several European institutions and manufacturers. With 1/3 of the Pilot Common project in operation and an additional 40% deployment ongoing, Cesar Deployment Manager delivered way ahead of the foreseen deadline. These modernization projects in operation save time, fuel and trees for EU passengers and citizens and generate payback for the economy while digitalizing European skies. By 2030, 13.5 million minutes of passengers' time, the equivalent of the average flight time of 120,000 flights, will be saved. The first set of 150 completed projects will spare 280,000 tonnes of fuel by 2030, enough to power 44,000 average flights. The joint effort will also accumulate a saving of 880,000 tonnes of CO2, which compares to 1.8 million saved trees. In total, all these savings of time, fuel and CO2 from the first 150 completed projects are worth €775 million. With the support of all institutions and stakeholders involved, we are also coordinating the data link services and ADS-B implementation in Europe. We couldn't have achieved any of this without the EU's financial support, but the commitment of all Cesar deployment stakeholders remains the real engine of air traffic management modernization. This is their result and their journey. We are grateful for their unwavering ongoing support, and we promise to keep on guiding them as the modernization journey continues. The SESAR Deployment Manager function will keep joining forces to make air traffic management more effective, cost-efficient, scalable, and environmentally sustainable. The route to a fully modernized, single digital European sky continues, with the need to keep all stakeholders on board. Let's keep on delivering air traffic management modernization together.